Welcome to Quantum Physics in the Australian Bush. It's a series of small tutorials on YouTube that I'll give which explain quantum physics, starting off with subatomic particles like electrons, working up to atoms, molecules, and eventually onto silicon. And you'll learn the physics that professionals use rather than that which is given to you at school, which is easy to teach but not very useful, and that's called classical physics. From around 1900 to 1910, 1920 was its heyday, but after that it seriously fell apart. Now my journey through was a more complicated journey, and I learned this in different pieces. I'm going to reconstruct it in a much easier way for you to understand. And the most important thing is that you're going to learn things which are a bit different from what you are expected to do in tests at school. So let's go over, in this first introduction, what you have to write in your tests at school. This is the classical mechanics, and let's make it absolutely clear what you should do in school tests at the moment. Later on, we'll get into some more exciting quantum physics, and I'm sure you'll agree with me, it's just really fab.
This is a picture of the atom you'll be expected to draw in schools. It's got the blue negatively charged electrons which travel on the grey lines. So those lines don't exist, they're artistic impressions to suggest where the electrons will orbit. They orbit a large distance from the nucleus, which contains protons, and there should be two other protons underneath there to make up 8 protons, plus charged protons, and neutrons, neutral neutrons, which hold the nucleus together. Now the view is that the electron is about the size of a cricket ball on the outside of the MCG, and the nucleus is the size of a grapefruit. Now, spoiler alert is of course that there are no, from quantum mechanics, is that there are no surfaces in quantum mechanics, and indeed there's no large empty spaces, but that's a spoiler alert for later on. The real advantage of the school atom is that the dot electrons allow you to use Lewis diagrams where electrons are represented as dots, and you can see here using this allows you to see how oxygen is bonded. Another advantage of the school atom is that in metals it has big voids between the atoms, so this allows electrons to travel freely through it. And yes, there are spoiler alerts for this in future lessons which I'll give later on YouTube.